Hello everyone. So today I'm solving some of the questions of chapter number 1 and the other chapter, moment of force. So we have collective questions of these two chapters. The first one, which unit is not an SI unit? It is coulombs. Other three, those are SI units. The second one, a copper wire has a true diameter. This is a true value, and if you check out the data, the values are quite close to one another, so the values are precise, but these are not close to the true value, so these are not accurate. So the values are precise but not accurate. Third one, we need to find the percentage uncertainty in the density. So for that one, you first write down the formula of density. Then you realize something: density equals to mass over volume. Whenever the quantities are being multiplied or divided, you add the percentage uncertainties. So you find the percentage uncertainty of mass. How? 0.1 divided by 32.5 times 100. You get the percentage uncertainty of mass. Then you find the percentage uncertainty of diameter. That would be the same as the percentage uncertainty of radius. So in terms of the percentage uncertainty, the percentage uncertainty of diameter equals the percentage uncertainty of radius. Once you have found the percentage uncertainty of radius, then you realize that the volume of the sphere is 4 over 3 pi r cube. So that means you need to multiply the percentage uncertainty of radius by 3. Only then you'll be having the percentage uncertainty in volume. So what you do is 0.04 divided by 1.87 times 100, and then you multiply whatever the answer is with 3, so you get the percentage uncertainty of volume. Then you add the percentage uncertainty of volume and the percentage uncertainty of mass, so you get the final answer as 6.7. Calculation, you can do it by yourself. Let's take a look at the next one. Which statement about scalar and vector is correct? The second is the right answer, B. A scalar quantity has magnitude but not direction. So just an easy one. Let's take a look at the next one. So in this one, we need to find the resultant moment about P due to the two forces. What are the two forces? One of them is this one, 16 Newton. The other one is 5 Newton. The 16 Newton would produce anti-clockwise moment, and the 5 Newton one would produce clockwise moment. Since the moments are opposite, so we need to subtract their moments. So first we can find the moment produced by this force of 5 Newton. How do we do? 5 times the perpendicular distance of that force from the pivot. So 5 multiplied by 0.5 in meters, because all the options are in Newton meters. So you get 2.5 for the clockwise moment. What do you get for this force? How much moment? Now for this one, the distance is not perpendicular to the force. So what you can do is either you can resolve the vector, you can resolve the force into perpendicular components, and then you look for the component that is perpendicular to the distance, which in this case would be 16 sine 30. Or you can directly apply the formula. Whenever the force is making some angle other than 90, you can apply the formula FD sine theta. F is 16, distance is 0.5, sine theta, theta is given as 30, and this is the angle between force and distance, so you get the moment anti-clockwise 4 Newton meter. Now what is the resultant? 4 minus 2.5, you get 1.5 as a right answer. Let's take a look at the next one. When must an object be in equilibrium? So it has to follow the two conditions: no resultant force and no resultant torque. Then we have question number 7. You're given with 3 forces, and they ask you the question, what is not possible magnitude of the resultant force? Now think about it. What is the maximum force that you can get from these 3 forces? Well, in that case, all of the forces have to be in same direction, so you can add them, and the maximum that you can get would be 13 Newton. Now what is the minimum force that you can get from these vectors? Well, the minimum that you can get is, if let's say the 7 Newton force is on this side and 6 Newton force, you add these two, but on the opposite side, then you subtract these two, you'll be getting a minimum of 1 Newton. You cannot get any other force, you cannot get the resultant less than 1 Newton. There's no other way you combine these two forces so that the resultant force is less than 1 Newton. So 0 is mathematically not possible. So you cannot have a 0 resultant force if the values of force, three forces are these. Think about it. If one of the forces were 3 Newton, the second one 4 Newton, the third one 7 Newton. In that case, we could have a force of 0 magnitude as well, because we can put 7 Newton on this side, and then we can put 3 Newton and 4 Newton on the back side, and then we can join these two. Because these two are in opposite direction, these two would be subtracted. So 7 towards the right side, 7 on the left side, the answer would be 0. But we don't have any force of these magnitudes, so for this one 0 Newton, which is the option A, is the right answer. Question number 8, once again theoretical. What statement describes two forces in a couple? So they should not be in the same direction. Matter of fact, they should be in opposite direction. So C is the right answer. They produce 0 resultant force. Okay, let's take a look at the next one. Question number 9. You need to find the percentage uncertainty in the volume of the sphere. Write down the formula for the volume of sphere, which is 4/3 pi r cube. Find the percentage uncertainty in diameter. No need to convert the units, because in percentage you don't have the units. And secondly, you don't need to convert the diameter into radius, because whatever the percentage uncertainty of diameter is, the same would be the percentage uncertainty of radius. Okay, I've stated it many times. So the percentage uncertainty in radius or diameter is 0.1. Second value, uncertainty divided by principal value times 100. So you get 0.2, and then you multiply by 3 because you have the cube of the radius. So you multiply by 3 and you get 0.6 as the right answer. For question number 10, we have that we need to arrange the prefixes from left to right in their decreasing order. So kilo is the highest one among these three, milli is less than kilo, and pico is even less than milli. And in all the other options, the order is not being decreased. Alright, so for question number 11, we need to find the mass of the meter rule. And it is the uniform meter rule, so that means the center of mass or the center of gravity would be exactly at the midpoint. So how much would that be? It is, okay, so we need to find this one. We can call it M2, we can call it M1, and there's another force over here. We don't know the value of it, so it's okay. And this is a point where the meter rule is pivoted at the point 34 centimeter. Okay, at the 34 centimeter mark. So this is our pivot. So we can write down the formula in terms of the masses, not in terms of forces. M1 D1 equals M2 D2. This one would rotate anti-clockwise, this one would rotate clockwise. This would not produce any rotation, this force, the tension, because this force is passing through the pivot. Any force that is passing through the pivot is not used in the calculation. M1 64 times what is the perpendicular distance of that force, that mass from the pivot? It is 30 equals to M2. We need to find the value of M2, and the perpendicular distance would be 34, and fours are 64, 4 3s are 12, so 120 would be the right answer for question number 11. Alright, so let's take a look at the next one. Which diagram does not represent R as two perpendicular components? So if we need to draw the two perpendicular components, then the perpendicular components should not be along the direction of the vector itself. So for this one, C is the right answer, because in the option C, this one vector is exactly along the direction of the given vector. So a component of a vector cannot be in the direction of the vector. Okay, moving on to the next one. Question number 13. So we need to show the chart which is precise but not accurate. So the true value is 15. So the values should not be close to the true value, but they should be close together. So B is the right answer for this one. So you see in the option B, the values are quite close to one another, but they are not close to the actual value. And D is the one that is precise as well as accurate, but we have to choose for the precise one but not the accurate one. Okay, anyway, let's move on to the next one. The diagram represents system of coplanar forces acting at a point. The length of the forces, which system of the forces is in equilibrium. So in order for the system to be in equilibrium, the resultant of the forces has to be 0. So let's start off with the first one. So you can call it first force, this would be a second force, this would be a third force. Now head to tail rule says you draw the first vector, and then at the end of the first you draw the second one, and at the end of the second one you draw the third one. Now what is the resultant vector? The resultant vector is from start point to the end point. Now start point and end point is the same, we're not getting any resultant vector, so A is the right answer for this one. Then we have the next one. The speed of the airplane is 200. Okay, the wind blows from west at a speed of 85. Okay, from the west means towards east, and the vector is 85 kilometer per hour. In which direction must the pilot steer the airplane in order to fly due north? So he needs to fly towards north. So this is the resultant vector, because at the end of the day the pilot needs to travel towards the north. So this has to be the resultant vector. So where do we place the resultant vector? The resultant vector is the resultant vector starts from the starting point. Let me mark the starting point. When I was drawing the diagram, this was the starting point. So the vector that is the resultant vector always starts from the start point. So it would be here. And the second vector has to be connected at the end of the first one towards the resultant vector. Okay, so generally what we do is we draw the first vector, then we draw the second vector, and then we draw the resultant vector. But in this case we had to draw the first vector, then we had to draw the resultant vector, and then we indirectly draw the second vector. So this would be your second vector. And matter of fact, you can do it the other way around as well if you can guess the direction, because the pilot has to steer against the wind. So if the wind is on this side, then the pilot needs to steer the airplane probably in this direction. Only then the effect of the wind would be compensated, and the pilot would eventually be moving due north. So now you can solve this one. What do we need to find is we need to find the angle, and this is the right angle triangle, because this is north, this is east. So we do actually know that this is a right angle triangle. Alright, so once you have drawn the triangle, then you need to find which angle are you supposed to find. You're supposed to find the angle between the direction of the airplane, between the speed of the airplane vector, that one, and the north. So what is the vector that represents the speed of the airplane? It is this one. And where is the north? Well, you can draw the north vector over here, you can draw north over here, and you're supposed to find this angle, theta. Okay, so you can complete the triangle in this way just for the sake of convenience. It's all mathematics from here. So this side adjacent to opposite to 85 would also be 85, and then you need to find this angle theta. So you can use theta equals perpendicular, so you get 25 west of north. So exactly, to be exact, you get 25.15, which can be rounded off to 25.2. And what is the direction of this vector? The vector is in this direction, which is west of north. Okay, so if you draw the plane over here, this is north, east, south, west. So this direction is west of north. So 25.2 west of north. Okay, two parallel forces, each of magnitude F, act on a body as shown. What is the magnitude of the torque on the body produced by these two forces? So for the torque, you can use the formula. In the case of couple of forces, the torque produced by the couple of forces equals to the force times the perpendicular distance between the two forces. So you take one of the value of force, because both of them would be same. And what is the perpendicular distance between these two forces? Not D. D is not the perpendicular distance. One force is on this side, the other force on this side. The perpendicular distance would be S. So F into S would be the right answer for this one. So B is the right answer for this one. Okay, let's take a look at the next one. Question number 17. So this is a vector V. This is a vector V, and this is a component of the vector. One of the component of the vector V is along the direction X, and the other component of the vector V is along the direction Y, and the angle of that vector V with the direction X is theta. So the question is, how do the magnitude of X and Y change as the angle theta is increased this way? So what you're doing is you're going to increase the vector from here to here, and then probably over here. You keep increasing the angle of the vector. So what happens to the component of the vector in the direction X and Y? So you see, the closer the vector is to Y, the magnitude of Y would increase. The closer the vector is towards this side, towards X, the magnitude of that component would increase. So if you keep increasing the angle, the vector gets away from X and gets closer to Y. So the value of X would decrease and the value of X would increase. So for this one, we have D as the right answer. And matter of fact, if you increase the angle in such a way that angle is increased and now the vector is exactly in the direction of Y, well, in that case, the component along X would be 0. And the entire vector would be in the direction V, in the direction Y. Okay, then we have the next one. For this one, you need to find the resultant moment produced by the forces about the point P. So you can mark the forces first. This is your pivot. This point is your pivot. This one would rotate it anti-clockwise, anti-clockwise, and clockwise. So clockwise on one side, anti-clock on the other side. So clockwise we have 15 times the perpendicular distance is 3, and all the other ones we can subtract. 5 times anti-clockwise is 5 times, and what is the perpendicular distance of that force from the pivot? It is 4. The total is 4 minus 2, we get 2. 5 times 2 plus the other one anti-clockwise is 10 Newton, this one, and the perpendicular distance of that force from the pivot is 2. 10 into 2. Okay, and then you can hit it on the calculator. You have 45 minus 10, 45 minus 10 plus 20, you get 30. 45 minus 30, so you get 15 as the right answer for this one. So for question number 18, we have 15 as the right answer. Okay, let's take a look at the next one. What is the component of this displacement vector in the direction xy? So the simple answer would be 5 cos 53, because this vector in the direction y is the one that is touching the angle directly, so it would be represented by the expression cos theta. The last one, which pair of units contain one derived and one base unit? For question number 20. So with this one, A is the right answer. Ampere is a base unit, but coulombs is a derived unit. And in terms of base units, coulomb is represented as AS, ampere times second. Alright everyone, let's move on to the next part, which is a structure question. So here we have the first one. In the first one we need to mention two scalar quantities, two vector quantities. You can see that already. Two properties that are possessed by both vector and scalar. Be it vector, be it scalar, they must be having the magnitude, sorry, not direction, and they must be having a unit. So magnitude as well as a unit are being possessed by a vector as well as by a scalar quantity. So let us solve the next one. So determine the magnitudes of the components of the velocity of the ship in the north and east direction. So this is a vector, very easy question. You have the vector given over here, and the magnitude of the vector is 13 meter per second. You need to find the component along the direction north and one along the direction east. So this one along the direction north and the other one along the direction east. So the one that is along the direction north is touching the angle directly, is with the angle 35 with the vector of velocity. So it would be 13 times cos 35, and the other one would be 13 times sine 35, because the direction of the component of the vector in the direction east is not touching the angle directly. Then we can hit it on the calculator. So this one would be 13 times cos 35, we get 10.6. In 2SF we can write 11, and the other one we get 7.5. 13 times sine 35 would be 7.5. That too in 2SF. So very easy part. Let's move on to the next one. The ship now experiences a tidal current. So just like the question of the airplane, they add another vector, which is the wind. So in this one they have added the other one, which is the tidal current. The water in the sea moves with a velocity of 2.7 meter per second to the west. Calculate the resultant velocity component of the ship in east direction. So previously the component of the vector towards east was 7.5. Okay, we calculated it already. It was 7.5. So we can write 7.5. It was there in this direction, east. The vector was 7.5 meter per second. Now the ship experiences a tidal current in the direction to the west, so it would be in this direction 2.7 meter per second. Now what is the resultant velocity in the direction east? Well, it would be the difference of 7.5 and 2.7, because the 2.7 vector is opposite to the direction of the first one. So what do we get from here? We get 4.8 meter per second. Let's take a look at the next one. So for kilo, 10 to the power 3, tera is 10 to the power 12, and pico is represented as p, and the exponent is 10 to the power minus 12. So the prefix for which the exponent is 10 to the power minus 12 is pico, and tera is 10 to the power 12. Okay, so we need to underline the SI base unit. Ampere is the SI base unit, meter is the SI base unit. Okay, let's move on to the next one. We need to find the percentage uncertainty in rho. Rho, which is the resistivity. Okay, so first of all we need to write down the formula. So rho equals to VD square over Li. So rho equals VD square divided by L times I. Okay, so what do we need to find is the percentage uncertainty in rho. So the percentage uncertainty would be the sum of all the percentage uncertainties of the quantities in the formula. So how much do we have for V? 3.5 plus how much do we have for diameter for D? It is 3, but we have D square, so it will take 2 times of 3 plus percentage uncertainty for length 2.5 plus the percentage uncertainty in current 2.0. Then you hit it on the calculator. 3.5 plus 6 plus 2.5 plus 2. What do we get? We get 14. Okay, 14%. And we'll write the percentage uncertainty in 2SF because all the percentage uncertainties were given in 2SF. Now we need to find the absolute uncertainty. In order to find the absolute uncertainty, you need to find the principal value of rho first, the principal value of resistivity, and then you find how much 14% is of that principal value. So, but the principal value is given already, and you don't need to find it. And that's why the question is for 1 mark only. So the principal value is 4.1 into 10 to the power minus 7, and you need to find 14% of it. So you hit it on the calculator. 6 into 10 to the power minus 8 ohm meter. Alright, so absolute uncertainty, we generally like to write the absolute uncertainty with only with 1 SF. This is the absolute uncertainty that you can write. You can write in 2 SF as well, but generally the tradition is, the convention is we write in 1 SF. Alright, for the next one, state the principle of moment. You can write down the same definition as it is. For an object in equilibrium, you write down this phrase, only then you get both the marks. Let's move on to the next one by using the principle of moment. By using moments about point C, pivot C, calculate FB. We need to calculate the force FB, this one, and this is considered as the pivot. Alright, let us apply the principle of moment. So if the point C is considered as a pivot, this force FC is out of the equation. It would not be even used because this force is passing through the pivot. So we have one force, this one, second this one, third this one, and this is your pivot on at the point C. So this one is going to rotate it clockwise, and this one would rotate it anti-clockwise, and this one also anti-clockwise. So let us add the moments, clockwise on one side, anti-clockwise on the other side. So FB times, what is the perpendicular distance of that force from the pivot up till here? So if we try to find the perpendicular distance of that force, this one would be a total of 9, and we can subtract this distance from the total distance of 9 and also this distance. So the total distance is 9, okay, and you can subtract this distance and this distance, 2 meters from the left side, 2 meters from the right side. So you'll be left with the distance of the force FB from the pivot up till here. So 9 minus 4, you'll be left with 5. So FB times 5. Okay, so plenty of ways you can find the distance. It's not a very tricky thing. You can do it your own way as well. Then let's take a look at the second force, which produces a clockwise moment. That is 380 Newton. Now what is the perpendicular distance of that force from the pivot? It is from here all the way till here. And how much is that? Well, it is 4.5. all right, so we have this distance, a total of 4.5. How do we know? Because it is a uniform beam, and 380 is the weight of the beam. So weight is always passing through the midpoint if it is a uniform beam. So on the right side we have 4.5, and we need to find this distance only. So we can subtract 2.0 from 4.5, will be left with the distance of 380 force from the pivot. So we'll be having 2.5 plus, then we have the second force, the third force, sorry, 750 times, what is the perpendicular distance of that force from the pivot? 3.6 minus 2. So you'll be left with 1.6. So from here you can do the calculation. 750 into 1.6, 380 into 2.5, then you add these two, whatever the answer is, you divide the answer by 5, you'll be getting the answer for FB, which you'll be getting as, let me hit it on the calculator, 430. And to SF you'll be getting 430. So the calculation is shown over there. Alright, let's move on to the next part. This is of 2 marks as well. The man walks towards the ND. Okay, so this guy is walking towards the ND from here, probably over here on this side. Alright, for this one, what you can do is you can apply the principle of moment at the point C. Okay, once again you can apply the principle of moment at the point C, but that force is now being reduced to 0. Which force? This one. This force is being reduced to 0. So this force is not there in the expression. What are we left with? We are left with a force of 380. We are left with a force of 750. These two forces. And pivot is just the same. So FC is not there. So FB is removed from the expression because the value is supposed to be 0. So we're left with 380 times how much? 380 times 2.5, the same. First 750. Now the thing is, what is the perpendicular distance of that force from the pivot? Let's suppose here you have the distance x, distance that the person can get close to the point D so that this beam does not fall. So we can write here 2.02. The distance we can write is 2 minus x. So when we write down this expression, the thing was 750, this is a force 750, but the perpendicular distance of that force from the pivot, we're not sure about the perpendicular distance of that force from the pivot because the value of x needs to be found out. What we know is we need to get this person as close to the point D as possible, and the perpendicular distance of this force 750 force from the pivot would be 2.0 minus this minimum distance, because this minimum distance has to be there, otherwise the beam would tip over. Okay, the uniform beam would fall, it would tip over. So you have to keep this distance. So from the total distance of 2, from the distance of 2 meters, which is the distance from the pivot, the person has to have the distance of x meters, otherwise the tip would fall. So you subtract x from there and then you get the minimum distance, the value of x. Alright, let's move on to the next one. We need to find the SI base units of K. So just an easy one. We can take square on both sides, so we can get rid of the square root over m. Alright, so now what we can do is we can insert the base units. For example, for t square we'll be getting the unit second square, for m we'll be having kilogram, and for the distance we'll be having cubic meters. So S2 kg m minus 3. So these are the base units of K. Let's take a look at the next one. We need to calculate K and its actual uncertainty in the SI units. So the thing is, all the units are given in the SI base units. All the quantities are given with the SI base units. So we need to find the value of K first. So we use the formula K equals to T square m over R cube. T square m over R cube. Let us insert the values directly. You can do it on the calculator, straight away on the calculator. And once you insert the values on the calculator, the value of K you will be having would be 5 5.9 into 10 raised power 11. So you hit it on the calculator, insert the values as it is. The value of k would come out to be 5.9 into 10 raised power. Let me check. 5.9 into 10 raised power 11 into SF. Why into SF? Because the least number of significant figures on the raw data is 2 from here. We have more than that, but we always go with the least number of significant figures. Now we need to find the actual uncertainty or the absolute uncertainty. Well, in the formula we have t square. So the uncertainty of t would be twice of the uncertainty of t. It would be 1% from here. And for the mass we have 2%. So 2% for the mass plus 3 times the uncertainty of r, which would be 3%. So we get a total of 6%. But then 6% of what? 6% of the principal value. So 6% of 5.9 into 10 to the power 11 times 6%. Now we can find what is the 6% of this value. Let me hit it on the calculator. So for this one we get 3.5 into 10 raised power into 10 raised power 10. Okay, so this is what we get for the value of k. SI units, the units are written as it is. You don't need to write the units, but we need to represent the uncertainty with so that the rules of writing the uncertainty with the principal values are not violated. So let me write down the answers that we have first, and then we can check out the rules. 5.9 into 10 to the power 11 plus minus 3.5 into 10 to the power 10. So this is what we have so far. Now the first thing is, what is the least number of significant figures in the uncertainty? The least number of significant figures in the uncertainty is 1. So you need to round off the uncertainty as well in one significant figure. So in one significant figure, the principal value written as it is, principal value is already in consistent number of significant figures, which is 2. And for the uncertainty, it would be 4 into 10 to the power 10. And if you remember the second rule, the exponents should also be same. So if for the first one it is 10 raised to the power 11, the second one it should also be 10 raised to the power 11. So what we can do is we can change the exponent of the uncertainty, and it can be written as 10 to the power 11 plus minus, for the uncertainty we can convert it this way, 0.4 into 10 to the power 11. All right, that would be the same thing. So now we can write the final answer as it is. Both ways would be fine. 5.9 into 10 to the power 11 plus minus 0.4 into 10 to the power 11 SI units, or you can also write it this way. Yeah, that should be fine. So this is what we get for this question. Let's take a look at the next one. A spherical ball of radius r. Okay, we need to find the SI base units of C. So C equals F over RV. If we rearrange, then the SI base units of F is kg ms minus 2. For R we have meters. For speed we have ms minus 1. Then kg written as it is. One of the meters cancelled away. And s would be s power minus 2. Minus 1 coming from downstairs would be plus 1, and s would be minus 1. So kg m minus 1, s minus 1. This is what we have for this one. Okay, let's take a look at the next one and the last question. Nano is 10 raised power minus 9. Centi, the symbol is small c. Mega, it is 10 raised power 6. This is mega. And 10 raised power 12, the symbol t, it is tera.